Diffusion models is you have a forward diffusion and you have reverse diffusion. Okay, let me explain how it works. I don't know if you know the game show called Wheel of Fortune. It's an American show, it's very popular. Let's say the text prompt is a dog walks on the beach, right? And then diffusion models works like this. It starts with an image of complete noise. And then based on the hint, in this case, the hint is a dog walks on the beach. And then the model will fill in the blank gradually through many iterations.
What about video? How can we go from still images now to video? I've seen a lot of announcements, and I've seen there was that model from OpenAI, I think it was called Sora, right? But as of today, all of the video generation seems to have all these funny problems.
I think there's a lot of potential on text to image generation going forward.
So, Mark, let's jump straight into the book. Write a book like this. Why is it important that people know this?
This goes back to 1.5 years ago when I was still writing my book number 4. And Money actually has a very good system. After you finish 1/3 of the book, they send all the chapters to about 15 reviewers for feedback. So 3 rounds of feedback actually was extremely helpful. And in my proposal for my 4th book, I didn't plan to write anything about text to image generation. So for listeners who don't know, my 4th book was about generative AI. And in that book, I was mainly talking about how to generate image with GAN, BAE, and also how to generate text, so on and so forth. And then a couple of reviewers mentioned that now text-to-image generation is a new trend, and a lot of readers wanted to know more about it. Because of that, I added 1 chapter in my 4th book. So the chapter was about diffusion models, the general idea. And it turns out that that chapter was very popular, and a lot of readers really liked it. And it also prompted me to spend more time on exactly how text to image works. And obviously you have like a DALL-E, you have Stable Diffusion, you have Google's imaging, and so on and so forth. And I found out that there are 2 approaches to text to image generation. The first approach is diffusion models. So the idea behind the diffusion models is borrowed from thermodynamics. I will get to that a little bit more. So that's the first method. And now it's become the dominant method. And the second method is transformer-based. Transformer-based means you convert an image into a sequence of image patches. And then when you predict, like when you generate a model, you generate a patch by patch, like a sequence. When you generate the text, you generate 1 word at a time, right? Sequentially. When you generate an image using transformers, you use the same approach. You basically generate the image patch by patch. And let's say you divide an image into a 16 by 16 grid. So that way you have 256 image patches starting from the top left corner, and then the patch to the right in the first row, and so forth. And just based on the text prompt, you generate 1 patch at a time. Once you finish all 256 patches, you have an image. So that's the first way. The second way is diffusion models. Diffusion models is you have a forward diffusion and you have reverse diffusion. Okay, let me explain how it works. I don't know if you know the game show called Wheel of Fortune. It's an American show. It's very popular. So what it does is it has a big screen, several words on it, right? And it only shows a few letters, and then it has a hint. And then you have to guess the words based on the hint, right? Diffusion models is like that. So what it does is it hides out part of the image and then give a hint to the model. And the model has to guess the missing parts, okay? You do this with many examples, let's say millions of examples. And if you show millions of examples, each image will missing some parts and you have a hint. And then you have millions of examples, and then the model will learn to fill in the blanks, right? And then once the model is trained, what you can do is that you can actually give a blank image to the model and you give the hint. And then the model is going to fill in the blank. Let's say the text prompt is a dog walks on the beach, right? And then diffusion models works like this. It starts with an image of complete noise. And then based on the hint, in this case, the hint is a dog walks on the beach. And then the model will fill in the blank gradually through many iterations. And then eventually a clear image of a dog walks on the beach will show up. So that's how it works. So basically, that's the whole book. The book is basically explained step by step how diffusion model works. And I started with a very simple examples of diffusion, how forward diffusion works and how reverse diffusion works. And then you gradually get to the state of art models, like stable diffusion, that kind of stuff. So that's the first approach. The second approach is transformer-based approach, right? So there I started with a classic paper, a group of Google researchers in 2017 published a paper called Attention is All You Need. So I'm sure you heard about that paper 1,000 times, right? Because basically that's the paper started the AI revolution in recent years. Okay. Chapter 2 of my book, Build a text-to-image generator from scratch. Chapter 1 is a summary of the book. And the chapter 2, I start with how attention mechanism works, how to build a transformer to translate German to English. The original paper by Google researchers, Attention is All You Need. So that paper is designed for machine translation. So once you have a model, you can translate between any languages, between Chinese and English and French. So the same model can be used to translate any language. You have an encoder, you have a decoder, you have a attention mechanism. That's the main ingredient of the model, which can capture the interdependence among different words in a sequence. So that's why it works so well. And so that's chapter 2. And then chapter 3 is about vision transformer. So the original transformer paper is for text, right? So how to generate the English text and how to generate French text based on English phrase, so on and so forth. Which is very natural because when you talk about text, it's sequential, right? One word is before the other and so on and so forth. But image is not a sequence, right? It's just that you see the whole image or you either see the whole image or not, right? Vision transformer is a very ingenious approach to image generation. So instead of treating an image as a whole, it treats an image as different patches. And then those patches are arranged sequentially, right? And then you can treat it as a sequence. Once it's a sequence, then you can use the transformer model to process it, to predict it, that kind of stuff. So that is chapter 3. And then In chapter 4, I started to add captions to images. Okay. So that's actually a very fun project. Okay. It's the reverse of text to image generation, right? For text to image generation, which means the input is text, right? A dog walks on the beach. So that's the input. The output is an image, right? But adding caption is the reverse. So the input is an image. And then based on the image, you need to generate the caption. You basically need to generate a text for the image. But it's a very useful exercise, and it's much easier than generating an image from scratch because text is sequential by nature. All you need to do is that you need like an image encoder. So you have an image encoder, read the image and grab the main features in the image. And then you so that's the encoder part of the model. And the encoder captures the essence of the image, pass that information to the decoder. And then the decoder is going to generate text based on the information from the encoder about the image. Okay. So if you show an image of, say, horses running in the grassland, and then once you put that in the model, the encoder will encode that information, pass on to the decoder, and then the decoder is going to generate text, one word at a time. Okay. In the first iteration, it will generate a word like A. Maybe the second iteration will be horse. At the third iteration, it will generate a word like bronze, and so on and so forth. So that's a very good exercise. And with these 3 chapters, chapters 2, 3, and 4, basically readers will have a good grasp of the attention mechanism, transformers, so on and so forth. And then I get to the basics of the diffusion models. Chapter 5 is about the basics of diffusion models. I started with a very simple model. It starts with grayscale clothing items. So those images are like has only one color channels, and it's only 28 by 28. So the number of pixels is very small. So it's very easy to process. And you can actually train a diffusion model to generate clothing items like a t-shirt, a dress, so on and so forth. And so what you do is that in the training set, you have a lot of images of different clothing items, right? You add some noise to those images, and then you feed those noisy images to the model, and the model learn to reverse the image. So figure out what is the original clean image. And if you give the model enough examples, the model can back out the clean image based on the noisy image. And then once the model has learned to do that, then what you can do is that you can give the model an image of pure noise. The model will generate the clothing items for you. So that's basically chapter 5. And it's readers learn to code from scratch, how to create a diffusion model, how to train it, and how to generate clothing images. And then in chapter 5, so you have 10 types of clothing items, right? You have t-shirts, you have trousers, you have a dress, so on and so forth, right? And then when the model generates images, it can generate any type. And beforehand, you have no idea what it will generate, whether it is going to generate a t-shirt or a pair of pants or whatever. So here's the natural question. The natural question is, how can I tell the model to generate a t-shirt instead of a dress? You can have a conditional model. So you will code in the class information. Let's say you have 10 types. Then you have type 0 to type 9. Based on those types, the model will generate the type you want. So that's the idea. And this has a very significant consequence for text-to-image generation because text-to-image generation is basically a conditional generation. So the model needs to generate the image based on the conditional information. The conditional information is the text prompt. So that's why chapter 6 is a very important chapter. It basically gives readers an idea how the conditional information is incorporated into the diffusion model. And then chapter 7 is about how to generate high definition images. So if you look at the state-of-the-art text-to-image generation models, the image looks stunning, right? It looks very realistic. It looks like the real thing, right? So it's just a lot of deep fakes. How to do that? So that's basically what chapter 7 is doing. So chapter 7, you actually have to incorporate the attention mechanism into the diffusion model. Why you need that? Because a high resolution model has hundreds of thousands of pixels in it, right? It's very hard for the model to figure out which part of the image is important, which part of the image is not important. So the attention mechanism is very useful here because it highlights the important parts and ignores the unimportant parts. The attention is all you need. So that paper is not only useful for transformer-based image generation, it's also important for diffusion models because once you have very complicated diffusion model, you need the attention mechanism to help the model to figure out which part is important, which part is not. So otherwise, it's impossible for you to train the model. So that's why attention mechanism is also important here.
How far can you get with these things on your home? I don't know what you're using. Are you using like a beefed up MacBook or are you using your son's gaming card? How good can you get these models working from home?
Okay, that's a great question. With my son's old gaming GPU, I can do it with no problem. But once you get to the high definition images, it's very hard to do even with the best GPU, not because the computing power. It must make a lot of sense. Computing power is one thing, and then the training sample is another. If you look at the state of the art, text-to-image models, usually they train the model with tens of millions of images, okay? For people like you and me, right? Where do you get like tens of millions of high-quality images? Even if you have that, it's very hard for you to put on a computer. Even if you put those images on a computer, probably you will run out of memory because each image takes a lot of space, a lot of memory. I only talk about how to construct the model. Once the model is constructed, I will talk about conceptually how to train the model, but the book does not train the model from scratch. Instead, you can go to Hugging Face. Basically, there are several pre-trained models. So, for example, chapter 12, we talk about the stable diffusion, or chapter 11, maybe I talk about the latent diffusion models. We use pre-trained models from online. You download those models to your computer and then use that generate a model. So we don't train them from scratch. You do construct them from scratch, but you don't train them from scratch. Not because anything else, it's because it's very hard to gather tens of millions of images. And even if you have tens of millions of images, it's very hard for you to train on your home computer. But you can generate based on the pre-trained model on your own computer. So that's no problem. So that's basically what I did in chapter 11 and 12.
Okay. But for a smaller image, like after reading your book, just try to visualize. We've all used Midjourney, and a lot of people now use the ChatGPT as well. They just look magical. Apart from that magic, can you get at home with smaller images?
Stable Diffusion is open source. So therefore, you can basically download the printing model to your computer and you can generate the image. It's the same way as you do it on browser through API. But if you look at OpenAI's DALI 2, even DALI, they are not open source. So you can do it with like an API through on their website, but their model is not open source. You cannot download the model to your computer and do it in Python. Okay. But in chapter 13, I talk about how to generate the image. Like there is a model trying to replicate OpenAI's DALI. The image resolution is pretty good. Obviously it's not as good as DALI itself, but it's trying to replicate what DALI was doing. And it works pretty well. It's generating the image sequentially, patch by patch. So to answer your question, for Stable Diffusion, you can generate state-of-the-art image, the same as Stable Diffusion API. But for DALI, because it's proprietary, so you can only have it's a replica. It's not an exact replica. It's like a project trying to replicate it. It's pretty close, but not quite there yet.
Okay, so is it true to state that diffusion models have been the forerunners? They have won this competition at this stage?
I think so. If you look at the OpenAI, probably you have the answer, right? OpenAI has DALI 2, DALI 3, okay? And the DALI is transformer-based. I think we talked about this a couple of times already. But the DALI 2 switched to diffusion models, mainly because diffusion models is better at generating high-resolution images. And there's a trade-off. So diffusion models is very computationally costly because what it does is that it refines the image iteration after iteration. Let's say you want to generate an image of a dog runs on the beach, right? So what you do is that you give an image of pure noise to the model. And then the model may denoise it for 100 iterations. Each iteration, it becomes clearer. And it's very powerful because it keeps on refining the image. The final image looks great, but you have to do it 100 times. The model has to work 100 times. It consumes a lot of energy, and also it takes a long time to complete the image. So that is a drawback. On the other hand, if you look at the transformer-based image generation, it's much faster because it just generates like one sequence, you're done. Okay, so DALI 2, you may need 1 minute to generate an image. DALI may only takes 10 seconds or 5 seconds to generate that image. So there is a small trade-off. On the other hand, if you have a supercomputer is extremely powerful, you can still generate high-resolution image very fast. But it takes like a lot of compute to do it.
What about video? How can we go from still images now to video? I've seen a lot of announcements, and I've seen there was that model from OpenAI, I think it was called Sora, right? But as of today, all of the video generation seems to have all these funny problems. Do we need another breakthrough, or are these existing technologies enough? They just need polishing enough to be usable for video?
I have been thinking about video generation quite a bit. And I also explored several papers on how state-of-the-art video generation works. There's like several models out there. One of the models actually is very similar to Stable Diffusion. It's called Stable Video Diffusion. So the idea is actually extremely simple, right? Stable Diffusion, you have a noisy image, and then you just gradually refine it until it becomes a clear image. Now, when you talk about the video generation, one of the models is actually, it's very clever. Okay. So what it does is that, okay, let's say you want to, by the way, like most of the open source video generation models, you only generate a video very short, let's say 3 seconds, 5 seconds, right? So to generate such an image actually is not that hard. Okay. So what you do is that, let's say a 3-second video, you may have 50 frames and okay. So you just simply play those 50 frames sequentially and you get a short video, right? What the model does is this, is instead of processing one single image, it processes a sequence of images. Okay, let's say you process 50 images at once. Okay, so you start with 50 images of pure noise, and then you gradually refine it based on the text prompt. And then after 100 iterations, you get 50 clear images. And then you just play those 50 clear images sequentially, you get a video. So that is the idea. It works to some degree. Obviously, you can only generate a fairly simple image based on this model, right? But once you go beyond a few seconds, if you want like a little bit complicated story, lasts several minutes, then this model will not work. But I have seen online some state-of-the-art models can generate videos several minutes long, and the content is very coherent. I don't really know exactly how those models work. And I don't know if those models are open source yet, because a lot of state-of-the-art kind of technology are developed by companies for competition reasons. They may or may not release how the model is made. So to answer your question shortly, it is fairly easy to extend, like I say, stable diffusion from still image to a very short video, just a few seconds long. But once you go beyond a few seconds, if you want like several minutes, you want to get like a coherent story, then that's a different story. And I haven't seen any open source projects on that. But I think that's a great research question. I think there's a lot of potential on text to image generation going forward.
Okay, Mark. So for anybody thinking now, this sounds amazing, I need this book, how can they access that? What's MEAP? And when is it going to be fully finished?
If you go to manning.com, you can find my book. Once you are there, you can either search for build a text to image generator from scratch, or you can search for Mocklew. The book will pop up. So right now, Manning actually has a Manning Early Access program, and it's a great program that lets readers read the book while the author is still writing the chapters. So my book is half done. The book has 14 chapters right now. 7 chapters are publicly available. So if you buy the book right now, you have access to the first 7 chapters. And I have already finished 11 chapters. And then by August, I will finish all the 14 chapters. I think late August, early September, readers will be able to access the whole book. And then I think the book should be able to be in print either at the end of this year or early 2026. So I think it's coming out pretty soon.
Perfect. Mark, Liu, everybody, thank you so much for coming again on the show.
Vico, thank you very much for having me.